Hi students, today we're going to do chapter 10, section 1. You might want to have your periodic table handy. Radioactivity. Radioactivity is a process in which an unstable atomic nucleus emits charged particles and energy. This was discovered by Antoine Henri Becquerel, and he was French. What happened is he realized that when he left some uranium salts in a desk wrapped by a photographic plate, a few days later the plate was exposed without exposing the uranium to sunlight, and so he got an image, and so that must have come from something other than the sun. So he figured that it was the uranium was emitting the particles. Radioisotope is an atom containing an unstable nucleus. And radioisotopes undergo nuclear decay. And nuclear decay, you should underline that one as well. I would underline nuclear decay as well. This is atoms of one element can change into atoms of another element. Some nuclear notation. We've talked about mass number and atomic number back in chapter 4, and it has been on every test, but just remember that mass number is the sum of the protons and the neutrons in the nucleus. The atomic number is the number of protons, and remember that's the number above the symbol on the periodic table. So when you are doing nuclear notation, we've got your atomic symbol here, and then the atomic number goes on the bottom to the left, and the mass number goes on the top to the left. So in this one, it has 6 protons, or if you look at carbon in the periodic table, its atomic number is 6, and then the mass number is the number above. So this is carbon 12. Types of nuclear radiation. There are 3 types. Nuclear radiation is charged particles and energy that are emitted from nuclei of radioisotopes. So whatever particle is being emitted when a radioisotope decays, that's nuclear radiation. The first one is alpha decay, and I would underline that as well. That emits alpha particles. Alpha particle is a positively charged particle made up of 2 protons and 2 neutrons. So it's a helium nucleus because it has 2 protons. The symbol is 42He. You need to make sure you know that. An example would be when uranium-238 decays, it emits a alpha particle and then it emits thorium. Do realize that if here's the arrow, the top numbers need to be equal on both sides. We've got 238 on this side, and then 234 plus 4 is 238 on that side, and the bottom numbers need to be equal. So we've got 92 on the left, then we've got 90 plus 2 on the right, so those are equal. This is the least penetrating, and it can be stopped by a sheet of paper. The next type we have is beta decay, and that emits beta particles. A beta particle is an electron emitted by an unstable nucleus. The symbol is 0 over -1e. You have to memorize that, so make sure you know that. An example would be thorium-234. It goes to 234.91 plus a 0 -1e. Do realize that this is a negative 1, so if you have -1 plus 91, that actually equals 90. And this is more penetrating. It can be stopped by a thin sheet of metal. Gamma decay is the worst. A gamma ray is a penetrating ray of energy emitted by an unstable nuclei. It has no mass or charge. The symbol is that, and it depends on what kind of font you're using when you're typing. I often will draw it like that, like a kind of like a ribbon. An example, gamma ray, since it has no mass or charge, is often just added on to either the alpha or the beta decay. So this one's beta decay because here's your beta right here, and then the gamma is at the end, and that's just added on at the end. It is the most penetrating. It can be stopped by lead or concrete. So we're going to do some practice. Writing and balancing nuclear equations. The mass numbers and the atomic numbers have to be conserved. They have to be equal on both sides. So we're going to complete the following. This middle one is actually the second one we're going to do. We're going to do this one first. So we've got 21884 PO yields 42HE plus. So we're going to complete it, and then we also need to identify it. So the first thing I would do is I would figure out the numbers for the missing particle. So we've got 218 on the left. We already have 4 on the right, and we're going to add something. So 4 plus what is 218? Well, that's 214. Now let's figure out the bottom number. We have 84 already on the left. We have 2 on the right. So 2 plus what equals 84? Well, that's going to be 82. To figure out this particle, we need to look at the periodic table. So looking at the periodic table, we want to look we want to look at, use the bottom number. The bottom number is going to tell us it. So we want to find 82 on the periodic table. So 82 is right here, so that's going to be PB. We also needed to say what type of radiation it is. So we've got alpha, beta, and gamma. Well, this right here is your alpha, so this is alpha. Now you should pause and try to do the next one. So we've got 146C. So we need to get the mass number and the atomic number to be equal. So we've got 14 on the left. We only have 0 on the right, so we still need to have 14. We've got 6 on the left at the bottom and negative 1 on the right. So negative 1 plus what is 6? Negative 1 plus 7 is 6. Now we need to use the 7 to figure out the element. 7 is N. So we'll put an N right here. This type of decay, the 0, negative 1, tells you that that is beta. Our next one. So now we need to figure out what goes on the left hand. So we've got on the right 222 plus 4 plus 0. That is 226. The bottom, we've got 86 plus 2 plus 0. So that's 88. 88 is right here. That is Ra. To figure out what type it is, we've got this and we have this. So this is alpha and this is gamma. So it has 2 types for this one. Okay, we're going to do 2 more examples. We're going to write a balance equation for the alpha decay of thorium-232. So first you should find thorium on the periodic table. Thorium is right here. It is number 90. So we're going to start with writing the symbol. The 232 goes on top and the 90 goes on the bottom. And it's decaying by alpha. So we're going to write our arrow and we have to write our alpha decay. That is 42He. Then it's going to have 1 more particle to make it balanced. So we've got 4 and we have 232. So what plus 4 is 232? Well, that's 228. We've got 2 on the bottom and we have 90. We need to get it to 90. So 2 plus what is 90? That's 88. So looking at the periodic table, 88 is Ra. Next, you should try the next one by yourself. So strontium is right here. It's number 38. So Sr 38, the 90 goes on top, and it's going by beta. So beta is your 0, negative 1 E, and we need to add something else. So to make it even on top, you're still going to have 90 because you added a 0 plus 90 is 90. Negative 1 plus what is 38? Negative 1 plus 39 is 38. And if you look on the periodic table, 39 is yttrium. That is not it. We have a few more things. Effects of nuclear radiation. Background radiation. Background radiation is radiation that occurs naturally in an environment. Air, water, rocks, cosmic rays, all of those have radiation that we're naturally exposed to in the environment. If nuclear radiation exceeds a certain level, then it is damaging. And it can cause skin damage and cancer. Detecting nuclear radiation. There are two ways to detect it. We've got the Geiger counter. The Geiger counter is this one right here. That you lift up this and you will hear it beep when it's near it. And then you also have a film badge. This is what a lot of people like in nuclear power plants will wear, or if you work with x-rays, you'll have to wear it and it just will alert you if you're being exposed to too much nuclear radiation. That is it for today's notes.